Alright, in 12.1 we're going to deal, or chapter 12 in general, we're going to deal with sequences and series. And what section 1 is just looking at what a sequence and what a series is. A sequence is nothing more, in layman's terms, a pattern. Okay, so we're going to look at patterns is what we're going to be doing. In the first example, what we're going to do is they're going to ask you to identify or list the first 6 terms. So they're going to give you a formula like this, where it's going to say a sub n equals 2n plus 1, or plus 5, and they want the first 6 terms. So what they want you to do, when they say a1 like this, they want you to put 1 in for n and see what you get. Okay? So our first step would be by taking 2 times 1, which is 2, plus 5 is equal to 7. Then I put a sub 2, which means I'm going to put 2 in and see what I get. So 2 times 2 is 4, plus 5 is 9. Then I continue on in that pattern all the way down until I get to 6 terms total. So if you notice that the pattern is going up by 2 every time, we can kind of bypass some of that steps and go right ahead and say 7, 9, 11, 13, 15, 17. So we have our first 6 terms. So they're going to ask you to identify or write the first 6 terms of the sequence for the first 2 problems in your assignment today. So all you're going to do is plug in the numbers 1 through 6 and see what you get. Okay? Sometimes you might have it in the exponent, and sometimes you might have it just like I had on this first example. If it's up in the exponent, remember to keep in mind that you have, if it's in parentheses, like this would be, it's negative 3 to whatever power it is. But if it says something like this, where it says negative 3 and minus 1, then it's 3 to that power, and the minus comes after it. So then every term after that would be negative. Okay? So if I ask you for the first 6 terms here, I'd have negative 3 in parentheses, 1 minus 1. 1 minus 1 is 0. So I'd have negative 3 to the 0 power, which anything, remember, is 1, but you also have it like so. Yeah, can't write. Then when you keep continuing on in that pattern, 2 minus 1, negative 3 to the first power is negative 3. Now over here, on the right-hand side, when you put 1 in there, you're going to take negative 3 to the 1 minus 1, and it ends up being negative 3 to the 0. This is going to be negative 1 because you are dealing with a negative after the exponent. So you've got to keep in mind the order of operations. Then every term was going to be negative. So if I have negative 3 to the 2 minus 1, I'd end up with negative 3 to the first power, which is negative 3. But it's on the third term for both of these where it would start to see the difference. You would have negative 3 in parentheses squared. And negative 3 squared over here is 9. But when you have it over here on the right-hand side, you have to do the exponents first, so that would be 3 squared, and then the minus would come after it. So notice the difference between the two, but that is what you're going to do for the first couple of problems, is that you're going to be inserting the number in for the letter and simplifying. See what you get, right? The first 6 terms is what they're going to ask you to do. Then the second thing that they're going to do is that they're going to ask you to write the rule. So they're going to give you a pattern, and you have to try to figure out what they're doing. So if I give you something like negative 1, negative 8, negative 27, negative 64, you have to try to come up with a pattern. Now, for most of you in geometry, you've had this before. You had a little bit of patterns before, but it might be something that you might not have seen for a while. But if you noticed on this one is, and maybe you did or maybe you didn't, but if you notice what's happening is that they're cubing every number. If I take negative 1 to the third power, I get negative 1. If I were to take negative 2 to the third power, I get negative 8. If I were to take negative 2 or negative 3 to the third power, I get negative 3. Negative 4 to the third power, I get negative 64, and so on. So in these examples, what they're going to do is they're going to ask you to describe the pattern, which we're just taking the numbers and we're cubing them. Then as far as writing the next term in our sequence, the next number on the list would be -5. So -5 to the third would be -125. And then as far as writing the rule for the nth term, this means that then no matter what I put in there, I could figure that out. And that's kind of the equation that they give you. If you notice, the only thing that's moving is the number that's inside the grouping symbol. Okay, it's going from -1, -2, -3, -4. If you look at just the 1, 2, 3, 4, 5, the next one would be 6 and 7 and so on. So how we write that is, because it was negative, we're going to put a negative n there to the third power. All right, so as far as the rule goes, that's what you're going to be doing. On another example, it's going to say 0, 2, 6, 12. And then it has that ... at the end. Just so that you guys know what those mean, if it has a ... at the end, like this does right here, see where it's got the 3 dots there, that is known as an infinite series, or sequence. Infinite meaning it continues on in this pattern forever. If it did not have the ... at the end, it would be what they call finite, which means it stops. Okay? So as far as what the pattern is going, if we can figure this out, anybody, or if you have not figured what's going on here, this number right here would be 0 times 1. This number right here would be 1 times 2. This number right here is 2 times 3. This number right here is 3 times 4. So if you notice what the pattern is going to be, the next one that is going to continue on in that pattern is going to be 4 times 5. And 4 times 5 is 20. Now some people might have realized that it went up by 2, up by 4, up by 6, so the next one would have been up by 8. That's another pattern, or another way of describing the same thing. Okay, so I did it a little bit differently the first time than I would have the second time, and then I could continue on in that pattern. The next one would be 5 times 6, or going up by 10, and so on. Now, writing the rule can be a little bit challenging. That's the part that's going to be tricky for most of you. As long as your pattern works for every number, or all of the ones that you have, then you should be good to go. Okay, the patterns that are going to be that it's not one specific pattern every time. There have been multiple times that I've looked at ones and seen that they've had different patterns, and they make sense and they work. And if that's the case, then we're good. Then I would give you credit for it. The pattern that I described was the one that was dealing with the bottom one, where I take the numbers, and if I subtract one from it, then multiply them together, I get the term that is the next one. So in this case, for instance, if I were to put 6 in there, for instance, for n, I'd have 6 minus 1 times 6, or 5 times 6, which is 30, which would be that pattern that I have established at the beginning. Okay, it wouldn't be just adding 10, just because if I were to add the 10 there, sometimes it gets a little tricky because it's not going up by the same number every time. If it was going up by the same number every time, that's something that we're going to deal with on Thursday. Okay. Now, as far as writing what they call a series, now a series is, by their definition, when the terms are added together. Okay? That's what a series is going to be when you add them all together. Finite series are going to be where I have, again, a specified number of terms, and I'm going to add them together. An infinite series would be where I have the 3 dots at the end. You're going to have what they call summation notation, and it's used by capital sigma. And capital sigma looks like the fancy-looking E thing. This means summation. Okay? What summation means, is, or where it comes from, is the word sum. Sum means to add. Okay, so what they're going to do is they're going to give you a number down here. Sometimes they use I, sometimes they use K, sometimes they use N. It really doesn't matter, but they're going to give you a starting point at the bottom. So it's going to say like something like a 1, and then on the top number is going to be a 5. This right here would be considered a starting point, and this would be considering your ending point, where you stop. Now, if you have the infinity symbol on the top, that means that it goes on forever in that pattern. And then on the left, or to the right of the summation symbol, they're going to give you the equation, something like 2n minus 3. Okay, and that's how it's going to look, where it's going to give you that summation symbol, and it's going to find that out, and you're going to be asked to find the sum. Okay, and so what you do for that is the first one that you would put in is you'd put a 1 in there. You'd multiply the 2 times the 1 and then subtract the 3 and get negative 1. Then you'd run a 2 through there. 2 times 2 is 4, minus 3 is 1. Then you'd run 3 through there. 2 times 3 is 6, minus 3 is 3. Then you run a 4 in there. 2 times 4 is 8. 8 minus 3 is 5. And then 2 times 5 minus 3 is 7. And there I would stop. And the reason why I'm stopping is because the top number told me a 5. So therefore that means that I am done right there with that one. Now to figure out the final answer, what you're going to do is take every single one of those answers and add them together. So the 1's cancel each other out. 3 plus 7 is 10, plus 5 is 15. And my final answer is 15. So when they're going to ask you to find the sum of the series, they're going to ask you to add up all the numbers after you plug them in. So very similar to the first example that we did where we put in the numbers 1 through 6 and see what we got. We're going to do the same thing. The only difference is I'm going to add those numbers at the end. So when they ask you to add them all, or if they give you that summation symbol, that is what they're referring or wanting you to do. Okay. The other thing that the last thing that they're going to have you do is they're going to have you do something like this, where it says write the summation symbol, or write the summation notation, and it's going to say something like 7 plus 10 plus 13 plus 16 plus 19. This is an example of a finite set because we start and we stop. There's not a 3 dots at the end. If there was 3 dots at the end, we would have it go to infinity. But in this case, it stops, and if you count, there are 5 terms. So we're going to pick an arbitrary letter. It doesn't matter what letter you use. I'm going to use K for this example. And I'm going to start with 1, and I'm going to end with 5. And now we have to come up with, if I put a 1 in there, or if you notice, I'm adding 3 every time. Okay, so that's kind of how the pattern works. However, if I start by putting in the number 1, 1 and plus 3, or 1 times 3 is only 3, not 7. So what I need to figure out is, from here, how do I go from a 3 to a 7? Well, I can add 4. That's what I can do. So if I were to take 3k plus 4, is that going to generate my pattern? Well, let's see. If I have 3 times 1 plus 4, I get 3 times 1 is 3, plus 4 is 7. Then if I take 3 times 2 plus 4, 3 times 2 is 6, plus 4 is 10. 3 times 3 is 9, 9 plus 4 is 13. Hey, I've got 3 in a row. I'm pretty sure that I got what I need. This problem and writing the rules are going to be the hardest parts for you guys today. That's going to be the toughest task for you guys to accomplish, is to try to get those formulas or the patterns down. Okay, do your best as far as how you do those. Those are going to be a little bit trickier than normal, but as far as coming up with them, that's how you're going to do it. Is that you're going to just kind of make a pattern and see if it works. And if it does work, great. You have the equation that goes in this piece right there. If it doesn't work for all of them, then you need to try again. Okay? And a lot of this is going to be trial and error, where you might not get it right away. Okay? So do your best as far as how to do that part, but as far as that goes, that should take you through the section 37 to 44, 45 to 56. That section, that's where you're plugging in the numbers and seeing and adding them afterwards and seeing what you get. Writing the rules for 15 through 26, writing the first 3 terms for 3 through 14, so we're good to go there. The only thing would be graphing the sequences that we haven't talked about. And as far as graphing the sequences go, like if you were to do number 28, it says -2, -5, -8, -11, and -14. And what you do on there is that if you look at my different terms, This is separated. This is the first term, second term, third term, fourth term, fifth term. And as far as graphing go, this is a little bit easier than normal. All it is like a scatter plot type situation where this is x's are 1 and the y's are what the pattern is. So for this particular case, I've got a 1 and down 2. Now this is a bad graph on my part because I didn't put that axis in the right spot. Let's get rid of that and start over. So if I put my axis there and I have that as a 1, 1, 2, make a dot. Then I go over to 2, 2, 3, 4, 5, make a dot. Then over to 3, 5, 6, 7, 8, make a dot. And that's what's happening is I'm just making dots as far as how that goes or how that looks. That's how you're going to graph the sequences. Try not to make those too terribly painful for you guys as far as how to do them. But as far as graphing them go, that's how they're going to look. Where you're going to put in whatever number that you get in the sequence number, that's the x-coordinate, and as far as the number it is itself, that is the y-coordinate. If you have big numbers, for instance, like I know one of them, I was helping somebody that had one with had like 2,000 something. Then you just kind of have to make your y-axis go up to 2,000 something, and then just kind of put them in there as best as you can for the other spots. Okay. So as far as the examples go, the first ones again, you're just plugging in the numbers 1 through 6 and seeing what you get. On 15 through 26, you're asked to describe what's happening, tell me the next term, and try to write the rule. 28 to 36, you're graphing, just like we have up there right now. 37 to 44, you're trying to write the summation notation, and the difference between the summation and writing the rule is really nothing other than there's an adding symbol, so that's why we need that sigma notation, that E. And then on 45 to 56, they're asking you to now find the sum of it, which means plug in the numbers 1 through whatever, and then add the numbers when you get all done. Okay, so I hope that helped. I hope that was easy to understand. A lot of it's going to be plugging in numbers and seeing what you get, but what you're supposed to do, or what I want you to do, is 798 to 799, 4 to 56, multiples of 4, which I know sounds like a lot, but really it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's only 14 questions. I think you guys can handle it. Okay? So if you have any questions, then you can ask me tomorrow. I'll be back tomorrow. I'm just at a training thing for today. So, all right. I will see you guys tomorrow. Later.